Now I'm excited to have Martin Catherall, who's a data architect at MOQ Digital, speak today. Martin has a very interesting background. He recently completed his MBA, focuses on DevOps and the impact that has on the software development life cycle, but also has extensive experience in the relational database world in the FSI space. So it's not usual that you see someone that's got a bit of a dev background also has a bit of a data background as well. So Martin is also a regular speaker on SQL Saturday events, so both in Australia and New Zealand. So you might see him around the chaps doing that. And he's very enjoys sharing this information with the community. So today we're very lucky to have Martin tell us all about what Cosmos is for the SQL professional. Over to you, Martin.
Okay, thanks a lot for that, Ben. That was a great intro. So yeah, I'm Martin from Brisbane, Australia. And just a bit of background about this this presentation. It's I don't know, in some ways it could be seen as fairly basic. Obviously the main audience is SQL Server developers or people who've got SQL Server experience and a kind of compare and contrast with the NoSQL world of Cosmos DB. But if you've got no experience in Cosmos or SQL, that's kind of fine as well. You probably pick up some details around how to get started in Cosmos. And even if you're a seasoned professional, there might be sort of tips and tricks in here that you have now got into the habit of, they're so common to you, you almost forgot them and you need to pass them on to other people. So I'm going to whiz through probably 10 or so, maybe comparison features, but really there's probably three big things that I'd like people to maybe take away from the session. First one is containers, and you might be tempted to compare containers and tables. The global nature of Cosmos DB, and you might be tempted to compare the global nature of Cosmos to things like availability groups and replication. And also the backup and restore features of Cosmos DB, and how maybe they compare to what is available in SQL Server. Because obviously doing backup and restore is a pretty fundamental task of a DBA and anyone within analytics. So what I propose to do is just whiz over to my next slide, introduce Cosmos DB, and it's a bit of a mouthful. Microsoft's multi-model, geo-redundant, planet-scale database. Sounds like introducing a heavyweight boxer, if you ever heard a referee introduce any of them. So we're going to come back to this slide, and I'm going to summarize. So we're not going to see any more slides for the rest of the presentation. But what we are going to see, we're going to jump straight into the portal, which I've got closed. No. Yep, going to jump straight into here, and we're going to look at the Azure portal. We're not going to set anything up. I've already got things set up. But what we are going to do, we're going to step through a few settings and kind of just going to talk about them, give a bit of an overview of how maybe that setting compares with the with SQL Server. Now, you've probably heard Cosmos DB, born in the cloud. It's only available in the cloud. It's not like SQL Server where there was like an on-prem version for many, many years. And then it gradually made its way into the cloud. And from there, now we've got SQL database. We've got managed instance. You can even run it on a VM. There's lots of different ways to run SQL. But, if you want to get started with Cosmos, do you need to, have a cloud account? Do you need to set up an Azure subscription? Or is there another way to get started? And yes, there is. Cosmos has got an emulator. And what you can do is you can set that up. It's very similar to the portal. For example, I've got it on my screen now. And if we just go in, we can set up things like containers here. We're going to talk about containers quite a bit shortly, but containers is where we keep data. We've seen them, Will talked about them. I'm going to dive into detail a little bit more. And we can create databases in containers. One of the things you will notice about Cosmos, either in the portal or on here, there's a lot of different links and a lot of help available to get you started. For example, over here, we've got links to model data, cost and throughput calculations. So as a DBA, I used to do a lot of health checks. And as I was going around doing health checks, I eventually came a time when people would start asking me about Cosmos and what they were doing. And I didn't know anything about it really at that time. That was about, 3 or 4 years ago. And the answers I'd give were, I don't know anything about it, but based on my experience of SQL Server, maybe it works this way or that way or whatever. And thinking like that can actually eventually get you into a little bit of trouble. I mean, it may work out fine. You may just be querying like one container. It's absolutely fine. But as you get into some of the more complex scenarios and you get more data in there, obviously you'll consume more resources, and that consumption will obviously result in a higher cost. And you might be doing things in Cosmos which are perfectly natural to you as a SQL Server professional, things like normalization and joining things, totally normal to you as a SQL dev, but contributing to a high cost in Cosmos. And then that's going to translate into, Cosmos is really expensive. It doesn't really have to be that way. And lots of people think like that, and it ends up giving Cosmos a bit of a bad rap, when a little bit of thought and a little bit of forward planning can actually save you a great deal of money. But one of the big things I will say about designing for Cosmos is it's probably going to be really important, more important than probably in SQL, although it's still important in SQL, to know what sort of workload you're going to be dealing with, what sort of queries are going to be coming in, and how you're going to be answering them, and how many there are, because that's going to have a really big bearing on the cost of this in the long run. But there are some really cheap ways to get started. So anyway, that's the emulator. So we're now in Cosmos DB. One of the big differences straight away is you'll notice that this is a Cosmos DB. It's called an account. So in SQL Server, we've got at the top level, we've got our instance, and then obviously we've got our databases and stored procedures, and the model that we all probably know and love in SQL Server. Whereas that's a little bit different in Cosmos DB. At the top, we've got an account. Underneath that, we do have databases. And then underneath the databases, we've got containers, where most of you would be used to seeing tables. So there's a loose analogy between the two of those, but don't think about them as a one-to-one match, certainly. So let's go in and just create something. We won't actually be sitting here waiting for creations to finish. I've got a few already made. So we'll just enter a name. And okay, so the first big difference between SQL and Cosmos really is the models that are available, or the APIs. So I've recently heard people refer to SQL Server as having multiple models because it's got things like JSON and XML. I'd never really thought of it that way. But in Cosmos, there are actually 5 different models. And you might loosely think them as database models. We're just going to concentrate in this presentation on the core SQL API, although the other two for Mongo and Cassandra will help you to put data into those models, and it should work exactly as it did for in a Mongo or a Cassandra. Table storage, very similar to the key value pairs that we've got in our storage accounts, and we've also got a Gremlin API. So we're just going to concentrate at the minute on the core SQL. And you might think just by the name, that's exactly the same as SQL Server. Now, there are similarities, but there are also big differences. So I just set this up in the West US, and we can either provision throughput, or we can go serverless. If we go serverless, we just literally pay as we go. Might be a good model in some scenarios, might not be. But what sometimes catches people out is this here, pre-provisioning in advance. So here we can see I've got 400 RUs, that's resource units, and I can service queries with a combined total of 400 RUs or 400 resource units. So how does that work? So let's say I provisioned 400 RUs per second, and let's say I've got a query that for argument's sake costs 10 RUs. So I can service 40 of those and every second, because that will take me up to my 400 RU limit. If I get 50 that come in that second, well, what happens? Well, they won't be answered in that second. They might be queued, and if they eventually get queued too long, you will receive you'll be throttled, as you say, resource limited or rate limited is something that you might hear quite often, and that will give you an error. And if you program something in your API, you're probably best wanting to retry, so have retry logic. And there's actually places where you can go and see what errors or not your queries have actually given you. So be very careful about that and monitor your workload very closely. So knowing what it's going to do initially is a great start, but monitoring it and seeing if you've got things coming in that are going to take you over your limits, because this is where it can get quite expensive. And so you'll also want to write your queries in a way that reduce the amount of resource units that we'll use. And we'll look at some examples of how you can do that shortly. Now, it's actually a free tier. I've actually exhausted mine in other ones, but you can actually go for a free tier here if you want. So that might be a good way to graduate from the emulator and things like that into like the free tier here. Then we've got, we can choose between our production and our non-production. Now, a lot of these options used to be on the same page, but if you notice here, up shows non-production. If I flick over to global distribution, that's going to set me up with no geo-redundancy and no multi-region rights. If I change that to production and flick back over again, that has now set me up with geo-redundancy and multi-region rights. So global geo-redundancy, as it says, if you provision in, say, West US, as I've done here at the moment, I can have another Cosmos in the region pair. Interestingly enough, if I change this over to another region, let's say Australia, when I find it, Australia East, and look again at the global, we can see now we've got availability zones here. So we didn't have that when we chose the West US region. So there are different options available for different regions. Now, even if we were to choose no geo-redundancy, behind the covers, there's 3 or 4 different replicas almost of your database that you can use there. So that's geo-redundancy. Backup policy is probably something that maybe as a database professional might take you a bit by surprise. So, because backups can be done on a timed basis almost. So here we've got the backup interval of 240 minutes, which is every 4 hours, and they're going to be retained over 8 hours. So these backups are only being retained. We're only retaining 2 of them. So we're doing backups every 4 hours, but we're only retaining them for an 8-hour period. So that's a little bit different than just setting them up yourself. So something that might take a few DBAs by surprise. Now, there is a backup policy that's recently come in to do continuous backups. And that's there at the moment. So we can change these around 2 days and things like that. You can experiment with them. We've got local redundancy. Like I say, if you've got local redundancy, you do have multiple copies behind the scenes. We've got encryption, similar to we got everywhere else. TDE, similar sort of thing, and all that. But let's can out of there. We don't need that anymore. Can't actually lost. I just go back to Cosmos DB. Sorry, I lost my close button there for a while, and we'll go into one that I provisioned earlier, so we don't have to mess around with things. And we're going to talk about globally distributing data. So here we've got our West US. I've just set this up in the West US with a region pair at the moment. I'll just click back on there. And if we want other regions, we can just click around. We can add them. And that, you might say, oh, well, SQL Server can do that too. But all these different regions can be writable. In SQL Server with availability groups, like we literally just got one write replica distributing data to the other read replicas anywhere around the world if we wanted to. But with Cosmos, this isn't the case. And also the latency is quite low. There's actually an SLA around the latency to do with like sort of 10 milliseconds and that type of thing. So you might have a question around that. Well, how does that affect the data that's being transferred between different regions? And whereas in SQL Server we've got like recovery models, and that would affect how your database passed off transactions to other replicas around the world. In Cosmos DB, we've got something called consistency models, and there's 5 of them. And I'll go from the very outside to what we call eventual consistency. You might be familiar with this with things like social media. If you enter data in, say, Australia, does it really matter if your friend in America or Europe or wherever sees that update straight away? So long as they see it relatively quickly, there's no big deal. So the thing about eventual consistency is like it's not really going to honor anything. Your writes that you put into the local database will eventually make their way to other replicas, but you've got no kind of guarantee that in what order that they will do that. But you still have many, many replicas around the world to do that. On the other side of that, we've got something that DBAs would probably be way more familiar with: strong consistency. When you put something into the database, you guaranteed to be consistent on all replicas before you can see it. Now that's going to bring up a big problem if you've got multiple replicas around the world, because you might enter something in Australia and then it's going to have to harden in, say, America or Japan or whatever it is before everyone else can see it. So Microsoft's obviously aware that there's two ends to that, eventual and strong. So they brought in something called session consistency, which is in the middle, and gave us basically 5 consistency models. Now, I have a problem remembering these, so I borrowed a blog post from my friend Will, who was on the presentation a minute ago. And session consistency, so clients that are outside the session are doing writes that will eventually be consistent. So this is the default. And between the default and the eventual, and the default and the strong, we've got 2 other consistency models. So going towards the eventual end, we've got something called consistent prefix. And I like the way Will's kind of summed this up in really a sentence. Reads in consistent prefix are guaranteed to never see writes that are out of order. If we go the other way, to the bounded staleness, which is towards a strong consistency, we can configure bounded staleness by either the number of versions, so your data actually gets versioned as it goes in, of the item, or by the time interval. So bounded staleness is kind of similar to strong, but you've got a window where you might see something that's not quite hardened in other places around the world. So that's a real big difference between SQL Server. It does, however, bring up some real interesting opportunities. If you've got a say a data center in Australia and you're a shop in Australia, you could have all your clients there go into the Australian database. Then you might decide to open something up in America. Same sort of thing. You get all your American clients going to a replica that's in America. So they're both writing, Australian clients write to the Australian replica, American clients write to the American one. Those two Cosmos databases are syncing in the background. Now, as a business case there, you would expect Australian people never to clash with American people and the two just merge, but not problematically. However, what happens if there is a problem? What happens if someone enters data in Australia and then they enter it in America at the same time and there's a clash? It's a pretty common question. Well, Cosmos DB has the notion of last writer wins. That's by default. So the person who entered it most recently, the last writer, will win the transaction. However, you don't have to accept that. You can write functions to take care of that logic all by yourself and basically create your own logic. But let's actually look at now. Let's go back over and we'll look at some stored procedures. So if you go to the Data Explorer, have I put stored procedures in here? I put stored procedures in one of these. It looks like it wasn't that one. So, but I can create a container. Now I have to give it a name. We've seen before that I could place my RUs on the account. I can also place them on a database, or I can place them at the container level. Here I'm going to place them at the container level. Give my container an ID. I'll just call it ID. And a very important feature of Cosmos is a partition key. Now, this is not to be really confused with the partitions in SQL Server. They are kind of similar. If we are, for example, partitioning our table by, say, state, we're getting people to enter their address, and we're partitioning by state. But we've got perfect control in SQL Server about what goes to what basically space on disk. We don't have that with Cosmos DB. We just think about these partitions as being logical. And what we want to avoid is hot partitions. So, for example, in Australia, we've got, say, 7 or 8 different states. If I partition by state, and I've got a lot of people in, say, Victoria, which is one of our states, hitting that a lot, I'm going to get a hot partition. And that's probably not a great thing. So maybe we can go a bit more granular, and maybe we can partition, say, by postcode. So I'm still getting a lot of people in different postcodes throughout Victoria, but generally speaking, the data is more evenly distributed around Cosmos DB. So it's a pretty key concept in Cosmos to place in our partition key. So think about that really well. And one of the things that might surprise you, just to round off, is containers. Now, in SQL, you'll think nothing of joining 2 tables, whereas in Cosmos, joining 2 containers can be an expensive query. You want to avoid that as much as you can. So you're probably thinking, well, joining's pretty fundamental. But you got to adopt kind of a different mindset, really. Duplicating data in a NoSQL world is a lot more acceptable than duplicating data in a transactional world or a relational database. So you might duplicate data in 2 containers, and then you've only got to query 1 container. Will result in a less costly query and won't cost you so many RUs, and that will translate directly into dollars and cents So partition key. So if you don't put a partition key in, that's another. Well, if you put in the wrong partition key, or you run a query that doesn't have a where clause that references your partition keys, your query has to fan out, and that's another expense as well. So 2 tips there to really make your database more cost effective. Try to avoid joins. Denormalization is kind of fine. And try and pick a good partition key, and always use a where clause in your queries that has your partition key in it. And that way you won't fan out across the various partitions, and your query won't be so costly. And keeping those 2 things in mind can result in some fantastic savings for you. So I'll just flick over to the presentation to summarize. We are nearly out of time, but born in the cloud, we've got the emulator we can use. We've got T-SQL versus JSON. Cosmos uses JSON, not T-SQL. The language, the subscriptions, the account, the database, the containers rather than the instance, and the database and the store procedures. Multi-models and APIs we have. Denormalizing and denormalizing, not such a big deal in the NoSQL world. Backups and restores. Plan these well, because if you need to do a restore, you actually have to get on the phone to Microsoft. Recovery models versus consistency models. Archiving, which Will touched on previously with the time to live, so I didn't spend much time on that. And finally, last writer wins. And so that was actually the last writer. And now I will hand back over to Ben and Serena, and wonder, are there any questions that have come in and you'd like me to answer?
Great. Thank you very much, Martin. That was very insightful. I was going to ask you just regarding, from moving from the relational world to the Cosmos world, how have you found, or what sort of types of questions are you getting people asking who are SQL devs, and what sort of questions are they asking you about moving to a NoSQL world, and what sort of mistakes do you think that a traditional relational dev would do?
Yeah. It's an interesting one. People tend to look at the NoSQL stuff and just go, oh, it's a database, and there's a database here, and the 2 things are the same. With maybe an obvious difference to start off with. One uses T-SQL, the other uses JSON. And then they'll think, oh, JSON's really flexible. So I've got all the benefits of SQL Server, and now I've got the benefit on top of using JSON. And they always tend to take it back to, almost use their relational database knowledge as a baseline. So they think Cosmos will work exactly the same with this additional feature on top. For example, flexibility of JSON, the multi-region writes, and joining containers is a fundamental thing to do. Whereas like in SQL Server, joining tables, no problem. Joining containers in Cosmos, probably may run into a bit of trouble there down the line. So I just think it's not really planning that well. So what I'd advise is to really dig in, do the groundwork. There's a lot of similar presentations that MVPs have done out there similar to this one, and they'll touch on different things. Other people will go into partitioning more deeply. But generally speaking, I would avoid taking your relational database knowledge and just thinking Cosmos offers certain features on top of that. That would be not a great way to think.
Yeah, so it's not like you take up the relational mindset and basically creating a container for each table or something to that effect.
Yeah.
But really focus on the data modeling side and change your way of thinking around not worrying about duplicating data and things like that.
I think that is well summed up. It is about mindset. It's also about opportunities. There's different opportunities you get with the NoSQL world. And if you're still thinking like a relational person, you're kind of limiting yourself with those possibilities. So basically, we all know about data. There's obviously a lot of crossover. We can take our data knowledge from one place to another, regardless of whether it's Cosmos DB or Synapse or wherever. Data knowledge holds true wherever we are. Just digging into those, what I'd say, fundamentals. For example, the time to live, which Will touched on in the previous presentation, is a great feature that DBAs would love to have in SQL Server. Save as archiving. When your record's 5 years old or whatever, it gets archived or deleted. So there's, like I say, different opportunities in NoSQL than maybe there are in the relational world.
Yeah.
Hey, Martin, thank you. Thank you so much for your time and for the session. We'll now move on to the next one. Right? Before we do that, I just wanted to let the audiences also know, do not forget our Twitter handle, which is #CosmosDBConf. Do tweet in about Martin's session, previous sessions, any questions you might have. We are also answering your questions on the chat right now. So feel free to keep putting on more. We are excited to be here and we want you to get your best, right?